Okay, so we will be talking about expressions and variables today. This is basically when we introduce the x's and y's and z's. So you hear about x's a lot in math. We use them often. So this is where we introduce them. And we're going to see what they mean, when do we need them, and how to deal with some expressions. Also briefly introduce equations today. So again, the infamous x and y, this is what it means, and this is where it comes from. So let's first talk about expressions and variables. Okay, so basically, when we say an expression, it's something made of variables and or letters. Expressions are made of variables. Variables, another word for variables is letters. Like I said, X, Y, Z, or A, B, C, whatever. We call those letters, or more accurately in math, we call them variables. So an expression is made of these and some numbers. So you can say combination. The combination of numbers, just regular numbers, integers, and letters. That's what an expression is. It's also called an algebraic. It's called an algebraic expression, not just an expression, algebraic. Algebraic. Okay, so an algebraic expression is, again, the short answer is numbers and letters together. X's and Y's with some numbers together, they make an expression. Again, another word for letters is variables. We'll see why we call them that in a moment. So here are some examples of these expressions. So something like 3x plus or minus 1. Okay, this is an expression, okay, an expression or an algebraic expression to be more accurate. Why do we say that? Because it's made of numbers and letters, maybe one letter or more, and some numbers, and also some operations. All the 10 best operations are found in an algebraic expression. So in this case, we have one variable and some numbers. It could be more or two variables, or two, for example, 5x minus 3y plus 7. That's also an expression. As you can see, we have two variables here. There might be some parentheses. For example, this 2x plus 1 minus 10 or something. So it's also an expression. Happens to have parentheses. So all the PEMDAS operations in addition to the letters. That's basically what an expression is. It doesn't have to be X, Y, Z every time. It could be any other letter of the alphabet. For example, A, B, and C. Maybe some numbers here, like that. That's also an expression. What else? It could also be in the form of a fraction. For example, you may say 5x plus y, maybe to a power. And here, you may have, for example, 3x or y to the second. Okay, actually, we don't need the power here. It's just right without the power. Maybe minus something. So as you can see here, that's also an expression. Okay, so don't worry about these now. Just look at them. Just remember the name. That's all we're doing right now. So the name is algebraic expressions. Why? Because there is numbers and letters in it. That's all. We'll see how to work with this in a moment. Another one of these is sometimes you may find something like this. You may see a variable like this repeated. See the same variable, but it's repeated with different powers. We have power 3 here, power 2, power 1, and so on. So all these, again, are called expressions simply because you see numbers and letters in them. Numbers and letters with some operations, with some PEMDAS operations. That's it. That's all definition of them. And so The reason why we use letters in math is because sometimes we don't know a value, we don't know a number, so we give it a name. X, for example, is unknown, or Y, or A, B, C. So when a number is unknown, since we don't know the value of it, we don't know what value to give it, 9 or 10 or -1, so we give it a name, just a label, until we find it, X, for example. And that's one of the reasons why we use letters. Another reason why we use letters in math is when something changes. For example, some value, some amount, whatever amount it is, it changes. Let's say maybe the phone number of students. Each student may have at least one phone number, and that number changes from one student to the other, or the social security number. So it's a variable. The social security number is a variable. So we could name it, for example, S. We could name that variable S for social security. And this changes from one person to the other. No two people have the same social security. So this is a variable because it varies. Okay, so because it varies, it changes, so we refer to it as S. Person 1 may have some number, person 2 another number, and so on. So that's why we call them variables, because they change in value. So we use letters to refer to values that are unknown or values that change or vary. That's why we call them variables. Let me give you an example of what we mean by that when we say something varies in value. Well, let's work with this problem. So we're going to talk about something called evaluating. Expressions. Okay, like I said, in the example of a social security number, we can call it X, we can call it S, maybe more meaningful, S for social, it changes. Or, for example, this expression, whatever this expression is, 3x plus 1. So the expression here, the value of it will depend on X. So X is a variable, it could change, could be 2, -5, could be 10, could be any value we may give it. Depending on what it represents, it could represent, like I said, a social security number, could represent, I don't know, the phone number, the price of an item, okay? Items have different prices, so each price varies from item to item. Again, hence the word variable. So let's say you want to evaluate this expression when X is, for example, 4. So when X is 4, what would the value of this expression be if X is 4? Or if X was 4?
13.
13, that's right. So this will depend on the value of X. So when X is 4, if you plug 4 here, it will be 3 times 4, which is 12, plus 1 is 13. So what we do is we plug X into the expression. And simplify it.
Repito, es chiquito.
Okay, and simplify it. Which means we're going to take this expression, we say 3. So 3x means 3 times x. So 3 times, we put some parentheses. We put some parentheses here, so the value of the expression.
Hello?
So we put x here, so we put parentheses here, so the value of x goes here. So 3 multiply x, 3 times whatever x is, plus 1. And that value goes here. Again, it has to be a multiplication. 3x means 3 times x, so 3 times whatever the x is. Then you use the order of operations to simplify. Which operation do we do here? Using the order of operation? Multiplication. So we evaluate 12 first.
Multiplication.
That's right, plus 1 is 13. So that's the value of this when x is 4. If x changes, this will also change. It will vary. That's why we call x a variable, because it varies. So when we evaluate, so evaluating means, again, remember, it means plug and simplify. When you say evaluate an expression, it's not add, it's not simplify. It's plug in and simplify, both. So that's what happens when x is 4. Now let's see. Let's evaluate it with a different variable. So when x is, for example, 7. Same one. Okay, same one when x is 7.
22.
Say that again. 22, you said?
Yeah.
That's right. So we're going to take, again, the x, plug it into the expression. So 3x plus 1. So the x goes here. So it'd be 3 multiply 7, which is plus 1, which is, again, 21, plus 1, which is 22. So now we got a different value. For example, we need to do your taxes. All depends on your income, family status, status, whether you're married or not, kids, and so on. So each person has their own formula. What varies is the variables that I just talked about, maybe your status, your job, your income, your location. So those are variables. They change from one person to the other. And then you plug those into some formula. You go to the tax guy, run some numbers, and then it gives you your refund or whatever tax you need to pay and so on. So that's pretty much a very small example of that. So we put in some numbers for one variable and we get some value. So this changes depending on a set of the values or variables. Okay, so it's all about plug-in and simplifying when you evaluate an expression. It could be as simple as this, or it could be something more complex like this, and so on. Let's look at another one, maybe this time with a couple of variables. Instead of just x, maybe x and y. So let's take the same one. So we're going to evaluate. Oh, 5x minus 3y plus 7. How many values or how many variables do we need for this one?
2.
We're going to need 2.
Two.
That's right. We need to know x, we need to know y. So x is this, and y is something else. Let's say 3 here and minus 2. So you will have the expression and you will have the values. And the questions say evaluate. So when you evaluate again, take the 2 values or more, whatever, you run them through the expression and see what the outcome is. So the value will depend on what numbers we plug in. So this will be, again, always leave some empty parentheses for the value. So 5x means 5 times x. In other words, you can also write it this way, 5 times. So when we don't see anything between parentheses and the number as we saw last time, this means a multiplication. So 5 times something minus 3 times the value of y plus 7. So you want to set it up like this. Very important to plug everything correctly. Now we're going to plug this here, that's 3. Plug the y here, that's -2. It is -2, not just 2. Okay, make sure you plug the value as it appears. We have -2, we put -2. This negative is from the expression. Here, x is 3, so we put 3. Okay, so now once you plug, as you can see, this looks familiar. That's what we spent the previous class doing. So we talked about the order of operations and so on. So once you plug, you simplify using PEMDAS. Okay, so you simplify basically using PEMDAS. So what do we do first in this expression? What do we do first to simplify?
Multiplication,
Parentheses.
multiplication.
The multiplication from the right side.
That's
I mean,
right.
left side,
So
sorry.
that's right. So you would look for parentheses, but there's no parentheses that need to be simplified. There's nothing inside. So next exponent, we don't have any. Then the multiplications, we have 2 of them. We have 1 here. Again, as I said, this is 5 times x, 3 times y. So we can evaluate both of those at the same time. Evaluate both multiplications. This is 15. Okay.
15.
Then you have
Plus 2.
Is that -6?
2 times 3. So
That's
So
gonna be
that's-
6 because that's a negative, right? Or a minus.
that's right. So this is a negative times a negative. So it would be,
Yeah. 6.
that's right. It would be
Positive
plus.
6.
It would be a
plus
positive
6
Right.
plus 7.
That's right, plus 7. So we've done the multiplication. Then we do left to right. When you end up with addition and subtractions together, we do left to right. So
28.
21 plus
28.
That's right. The final answer will be 28. So the only new step today is to plug. That's all. Plug or replace or substitute. The rest, just follow your order of operations, just like we did last time. So expressions or X's and Y's, they don't have to be, scary or confusing. They're just numbers. They're just numbers that happen to change, or numbers that we don't know yet. And sometimes we try to find them using equations. That's basically what all algebra is about. It's all about referring to numbers or values with letters, which we also call variables. Okay, so if you change these values, also this will change. The final value here will change. So for example, each individual has their own let's say variables, their own, like I said before, address, age, phone number, whatever. So when you do the taxes, it's all individual. It's all individual taxes. So you have your own X's and Y's. You could have many, actually, when you do the taxes, you have many variables. You have to answer like a bunch of questions, many questions. So those questions vary. And we run them through some program, TurboTax, or whatever, some expression that has many formulas and variables and this and that. It does some math, and it comes out to one number or something. It says this is your refund, or this is the amount you owe, and so on. Okay, so it may also look like this. Okay, the expression may look like this. We could even add some power here. Okay, so let's see how to evaluate this. Or something like this. It doesn't matter what the expression looks like. Really, it doesn't matter. All you do is basically plug and simplify. Plug whatever values are given and simplify. So evaluate this. Evaluating this expression. All right, so let's do that and break up. Okay, so evaluating this when, so we're gonna need one value here. It's just one variable. Let's say maybe, for example, 2, when X is 2. Okay, so the only thing again we need to do is you take the X, you plug it here instead of the X. So it's going to turn from an expression, it's going to turn from an algebraic expression into just an arithmetic. Arithmetic doesn't have X or Y or Z, it only has like operations and numbers. So this is going to be 5. So 5 plus 2, X is 2 here, plus 1 to the 3rd power minus 10. So that's an algebraic expression. Okay, algebraic expression because variables and numbers. This is just arithmetic. There is no X here, just arithmetic expression. So we use the order of operations to simplify this. So again, according to PEMDAS, what do we do first here?
Parentheses.
The parentheses.
Parentheses.
Always see inside the parentheses. If there is something to do, you can add these two together, and everything else stays the same. Bring it down, minus 10. Okay, we're done with the parentheses. What do we do after
Now we
that?
do the exponent.
We'll try the exponent, which is here. So it's not this yet. It's not the multiplication yet. Gotta do the exponent. That is
18.
9.
3 times 3 times 3.
18.
Oh,
Not
18.
18. Not 18. Not
Not
27.
27. So 3 times 3. That's 9.
Oh, yeah,
times 3.
27.
That's right. 9 times 3, that's 27. So this is 27. And bring the 2 down, 5 minus 10. That's good. So what do we do after that?
The multiplication.
The
The
multiplication.
multiplication. So our multiplication is here, 2 times 27. 54.
54.
Bring, that's right. Bring the numbers, the other numbers down, plus here, minus. So when you have addition and subtraction, again, we do left to right. So
One.
That first,
59.
That's
49.
49.
right?
49.
That's right. Final answer should be 49. So this expression, the value comes down to 49 when x is 2. And again, if the x varies, because x is a variable, if it give you another value of x, maybe -5, maybe 10, you run it through the expression same way, you get a different value. So everything values. So when we evaluate, so evaluating meaning getting the value of something. So the value of this when x is 2 is 49. It all depends on the expression, depends on the order of operations, as you can see here. Okay, does that make sense, everybody? Any questions so far?
Everything clear.
Everyone? Okay.
I'm good.
Makes sense.
All right, so please let me know, everybody, if you have any questions at any time. And let's
Can you
move
do an
on to-
example of the fraction one?
Sure, that's what I was going to do next.
Okay.
So the fractions. So as we saw here, the expression may have some fractions. For example, that one here. Let's do that over here. So it's also an expression simply because it's made of numbers and letters. Happens to be a fraction, but it's still an expression. How many values again do we need to evaluate this?
2.
2.
2 values. So we're going to
2.
need the x, that's right, and the y. So let's say, for example, the x is 5. Or maybe just 4. And let's make this one maybe -1. So carefully plug. We're going to carefully plug these into this and then simplify it. Be 5. So the x
It's gonna be 4,
would be 4. Okay. And the y is
-1.
negative over. So 3. Again, if you have 3 times the variable, 3 times the letter, put parentheses first, 3 times whatever that is, power stays -1. And
1. 1.
-1.
Negative 1.
-1. That's it. So now we're just going to use the order of operations to simplify this. So we can do both at the same time, each one with its own order. So each side of the fraction will have its own PEMDAS. So for the top one, of course, we're going to do
Parentheses first.
parentheses first. So 5. We do the parentheses, that's 3.
3.
Then go down to this one and also start a new order of operations just for this one. This will be
4 plus -1 is 3.
No, not negative 1. 3 is 3 by 1.
so it's not 3 by 1 yet. What do we evaluate first?
Mhm.
The
The
exponent.
parentheses.
Yeah.
I
So
mean, the
that would be
exponent. Sorry.
Exponent.
The exponent, that's right.
+1.
Right.
Mhm.
That's right. So -1 to the second.
Times +1.
That's right. It will be -1 as we saw last time, times -1. This turns into a plus. This is the base. We times it by itself, we get plus. +1 or simply 1. So this turns into 1. Bring down the 3. I mean, it's not here. The next. So it's going to be 3 multiply 1. Okay. So this is 1 minus 1. Back up here. That's 15. And here, 3
10
times
over
1.
2.
That's right. 3 times 1, that's 3. Minus 1, that's 2.
2.
And that's it. Reduce it if possible. You may write it as a mixed number, but most importantly, reduce it first if you can. 2 does not go into 15, that's fine. But always reduce a question or reduce the fraction whenever possible.
Professor,
I have a
Yes.
question.
Mhm.
if I put, oh, never mind, my bad.
I have a quick question. So the top part, it said 5 parentheses x plus y.
Okay.
So we had the -1. We canceled out the positive.
Okay, good question. So you can think of it this way. So 5, then you have 4 plus, and then you may say the -1 plus the y, the y is negative. So when you have two signs like that, we times them. So when you see nothing between parentheses on something like this, that's a multiplication. So we kind of times these two. So plus times a minus, that's why we have a negative. Plus times a
Okay.
minus, we have a negative. But
So-
we'll talk about the signs. If this was a minus, here also would be minus times a minus. It would be a plus here. Okay, so that's
Okay, so how did
technically
you
what
get the
this-
3 if we times the?
No, just the sign,
four.
not the number. We only
Oh,
times the
okay,
signs into one, not the number.
Okay.
Okay, so 3, 15 over 2.
Professor
All right.
Sharma, hi, you're gonna kill me.
Malika, yeah,
Hi.
it's been a while again, huh?
No, it's
Why
not
do you-
been a while. It
Why do you
was
keep
one-
skipping?
No, I'm not skipping. It was one class. My daughter has her asthma. They go
Mhm.
back to school now. So every time she goes to school, she come home with her asthma reacting. So I
That's
am
okay.
about to run out and go to the emergency room.
Oh, wow, I hope everything is fine.
Yeah. I'm trying to
Alright.
get it. I'm trying to get her to not take gym.
I understand. Okay, that's okay.
Professor-
You'll find everything on Blackboard.
Yeah.
Okay.
That's
so
what I
just
did.
catch up,
Yeah,
let
that's
me
what
know.
I did with Thursday.
Okay, right. No problem. So, hopefully-
Professor, are we gonna turn that into a
Thank
mixed
you,
question?
Professor.
Mixed
Fine,
number?
no problem. Yeah, you may turn this into a mixed number, but it's important to reduce it if possible. That's important. And it's not a problem if you don't turn it into a mixed number, but make sure you reduce it when it's bigger. All right, so we did that. Now let's do one of these here. Okay. Looks-
One second, Professor, can I please go back to the bottom? I was just trying to understand.
Okay.
The negative one, I understood. I'll just copy one, just give me 1 second, please, sorry.
Good.
Because
Go
I
ahead. It's gonna be here. Yeah, take your time. So
Yeah,
let's do
I
one
was
of
trying
those.
to,
Go ahead, you can copy.
Yeah.
So let's do another one. Sometimes you may see, like I said, something like this. Maybe basically one variable repeated, but with different powers. Something like this, and then maybe 5 here, and x again, and finally minus maybe 10. So as you can see, we have the same variable that's repeated. How many values do we need here?
One.
Just
One.
one, because it's the
One.
same variable repeated, so we're only gonna need one. There's no y. Just gonna need x. Let's make it maybe -2. Okay, let's make that -2. And you could have more variables, more x's, but it's not a problem. Just plug or substitute all of them with negative. So here's the best way to substitute this. So again, 3 times x, just put some parentheses, 3 times x, whatever x is, minus 5 times x. Okay, 5 times the value of x would be here, minus 10. That's the proper way. If you don't put the parentheses here, if you put just -5 and you put x to it, which is -2, this is wrong. This looks like a subtraction, but it's not a subtraction. It should be like this. It should be -5 times -2. If you don't put the parentheses, it looks like a subtraction. So that's why, again, always put some empty parentheses for your value first, then plug your values inside the parentheses. So 3 times, again, the value of x is -2. I'm going to put -2 in both. That's the x. Then again, that's the only new step today is basically substituting. The rest should be just like we did last time, the order of operations.
So
What
that-
exactly do we evaluate first here?
The exponent.
Exponent.
Exponent. That's right. Always do the exponent. first. So it's not
exponent.
3. It's not 3 times -2 yet. The exponent. Or if you have something inside the parentheses, like here, you would start from inside. So we're going to do this first. What is
Four.
-2 times -2?
Four.
Positive
Four.
4.
That's right. So -2 times -2 is like this. So your powers, do them on the side. Don't put them into the expression here. Don't break it down here. Break it down outside separately like this. Only bring the value here. So the value here is 4, but again, it's in parentheses, 3 times whatever this is. So 3 times 4.
That'll be 12.
Okay, in the next step, and let's bring down the other. Just gonna write down everything else. What do we do after
Then
the
3 times
exponents?
4
It's
plus
12 minus
Then-
-10.
It's 12 minus.
Okay. Now minus, we have -5
plus
times
10
-2.
minus 10
Oh, 12
plus
plus
10
10.
minus 10.
That's
the
right.
same
We have a negative
minus
times a
10.
negative would be a plus, and
Minus-
minus the 10.
And then the end is 12.
That's right. So by the way, you could do left to right, or you could notice that these two are opposite. You can just cancel them out and you say 12. The opposite numbers, they cancel each other out. You can cancel them out right away. The answer is 12, or you can do left to right. Left to right. So we're going to evaluate this first. That's 22 minus 10, and that would be 12. Okay, and that's the value when this is -2. If this changes, this will most likely change as well. If this changes, this will most likely change to a different value. Could be a negative, could be a plus here, so that would definitely change. Okay, so again, evaluating. Remember what it means to evaluate. Just means to plug or substitute. Then you use your order of operations to simplify. Again, we went over the order of operations and the powers also last time. This is in the previous lecture if you missed it. We talked about this in detail last class, also the order of operations. So make sure you review that if you missed that class. Okay, any questions so far, everybody? Everyone, let me know if you have any questions. So again, it's the just
What
plug
made you put the
simplify.
D?
Which D?
When you stroll back up, like if you to go back up,
Mhm.
like, I mean, go back down, sorry. Go all the way
Yeah.
back down.
The
You see
end?
how you was on your left-hand side, you see how you was inserting that D?
D, where is T?
The D for dog, right there. You see how he was putting D over the 3 over the
Yeah,
20.
the arrow.
The arrow, which arrow? Let me see. I put a lot of arrows just to, I don't know which one you're referring
Is,
to, but
is the equation the 5 plus 2?
I think those is
Oh,
arrows.
just
Those are
arrow.
arrows.
Oh, here?
Oh,
Yes.
those are
Sure.
arrows.
Just the arrow
Eyes,
first
arrow.
there.
I was
Alright.
like, D.
Okay, so that's an arrow. So now let's do another thing now. So evaluating expressions. Not always do you find these expressions written like this. Sometimes they come from word problems. Sometimes they're word problems we translate into this. It could be a sentence. That's what we're going to do next. So translating would be number 3. Translating sentences into expressions. There are a few words, there are a bunch of words actually that refer to operations. For example, for addition, there are many words. You can say add, you can say increase, you can say more, and so on. For subtraction, same thing. You could say minus something or subtract something or difference, and so on. So most of them are pretty obvious and pretty familiar. A couple of them can be very unfamiliar. So let's just review them. Review a few of them quickly here. For example, when you say sum, what do we refer to when you say sum of two things? What is the operation that we refer to?
Addition.
The addition, that's right.
Subtraction.
And what about when we say difference? Difference of two numbers or more. What does that mean?
That division.
Not division.
Sorry,
Subtraction.
subtraction.
That's right. So the difference is just subtraction. And when you say the product,
Multiplication.
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 that's right. And the last one,
That's division.
Division.
Quotation.
that's right. Quotient. So we say quotient. So whenever you see quotient, this means division. For example, what is the quotient of 6 and 2?
12.
No, quotient, not the product. Quotient.
3.
Three.
Oh, sorry.
Quotient.
Three.
Okay. That's right. So if you say product, that means multiplication. For example, what is a product of 4 and 3?
12.
7.
12.
That's right. So sum,
Oh, the
subtraction,
product.
sum.
I
Right?
need to.
Okay, so most of them again are pretty straightforward. Some of them can be unfamiliar, like these last two. These are, you will find, I believe there's a table in the book, a detailed table for all the operations and their meanings. For example, addition, you will find like a bunch of words for addition, subtraction, same thing, and they basically refer to the same thing because the language is versatile. There's always, you can describe the same thing with many words, colorful, different words. So most of those words can be straightforward, like I said, but some of them, if you don't know the meaning of them, just, you can look them up or you can simply check the book for the list or the table. So let's do some examples here, a few sentences into some expressions. Very simple here. So for example, the sum. So the sum of a number and 7. That's it. That's the expression.
Number.
It's a sentence. Let's translate this. How would you write this in an expression, meaning in variables and letters only, not in words? The sum of a
Professor,
number
what did
and
that
7.
say? Transitioning.
Translation.
The sum of a number and what?
Translating
X
sentences.
plus 7.
Okay.
And 7. That's 7. Oh.
X plus 7.
X plus 7. So that's right. So the sum of a number and 7. So again, the reason why we use letters in algebra or in math is because when we don't know the value of a number, for example, here, the sum of a number and 7. What is that number is? What is that number? We don't know it. So we're going to give it a name, just a label until we find
X.
the value of something. That's right. Could be X, could be N for a number, could be A, could be any letter. It doesn't matter. Just a name, just like we name people or name objects. Same thing here. So let's call this, for example, X. And of course, 7 is 7. And the sum again is sum, as we
Addition.
said, is plus.
Addition.
That's right. So the sum of a number and 7. So the sum is plus. And when you say sum or any of these words, that means there's going to be a couple of things on each side. It must be a couple of things on each side. It can't be just like that. And here, of course, the sum of a number and 7. That's it. We just translated this. That's all. Question?
Will we? Because I would have got confused and put a parenthesis of, over the 7 because of the of. Would you do that or no?
Sum of. No. The of does not always mean a multiplication. That's a misconception. I hear it a lot from students. It does not always mean multiplication. It all depends on the word. It all depends on the word. So the sum of this and this.
When you number, you mean product?
Product means multiplication.
Yeah, but you put the multiplication on number. So you mean when?
No, this is X. This is just X for the number.
Oh, okay, sorry.
So we use X or use N or use any letter. So just label it, basically label it. Let me give you another example, a little bit longer than this one. So let's say twice a number decreased by 6. All right, so another simple one. So first, again, you make sure you read the problem, the sentence, understand every keyword, especially the keywords, mathematical keywords. So what do we mean here by twice a number? If that number, for example, was, let's call it n. So what do we mean by twice n? That's right, would be 2n. So twice something means 2
minus
times.
6.
That's right, 2n, 2 times n, decreased by, of course, decrease, another word for subtract or something. And of course, this is 6. Let's write this. Actually, we already wrote it here. So what's the whole thing now together?
2 parentheses and
No parentheses, just twice n, twice a number. So we're gonna say 2.
That's our next one.
minus
Right.
6.
Minus 6. That's it, straightforward, there's nothing else. Twice a number, minus 6. Again, we use any letter to refer to the number. So it could be x, could be n, could be a, no problem. If you don't want to confuse it with the multiplication, you can use n or a. That's one example. Let me see, I'll give you another one. So let's say 3 times a, 3 times not a number, 3 times the difference of a number three times the difference and the number increased by, let's say, for example, 10. Okay, so this was a little bit different.
3.
So 3 times the difference of a number increased by 10. So there's a lot going on. So 3 times, of course, means 3 times something. 3
I think you have to
multiply.
delete the last and.
Number increased by, delete what?
That end over there. I think it should be 3 times the difference of a number increased by 10. But you put of a number and increased by 10.
Yeah, maybe 3 times the difference of a number. No, I need something here before the, I need something here. And 3 times the difference of a number and 4. Let's just put 4 here. Because again, the sum or difference, all of these, they have to be between 2 things. You can't just put one thing. And that and is 4. Okay, so 3 times the difference of a number and 4, and that whole thing is increased by 10. Okay, 3 times the difference again, that's subtraction. A number, let's call it n. Of course, this is 4, and increased is
Addition.
addition.
Professor,
So
why
the
are you
opposite-
writing 3x? Is that 3x? What is that?
No, 3 times, 3 multiply. Let me just
Okay.
erase it. Okay, so increased by, of course, this is 10. And again, when you translate, that's one thing. But when you write the expression, it doesn't have to be exactly like this, 3 minus n. No, that's not how it
No,
works. Maybe
it's 3 times.
it will work here. As you can see here, it did not work that way. It's not just right plus and the right x or n, whatever this is in 7. It's not always exactly this order. So think about the order of.
When you
But it does a 4, like a number 4 or
Mhm.
the word 4? I know.
n plus 4, a number plus 4.
Number plus
I
4,
mean,
yeah. The word
a
for,
number
the
and
number
4.
Yeah. So it's 3 times.
So 3
difference-
parentheses.
Very good.
Take
So
away.
parentheses. No,
Okay.
it's not takeaway. It's 3 times. So here, look, it says twice a number. If it says twice a number directly, that means 2n, 2x, whatever. But if it says 3 times something, so 3
3 parentheses.
times something,
N
thing-
minus 4.
N or X.
that's right.
N minus 4 plus 10. Close
Exactly,
parentheses
so-
plus 10.
That's right. So when you say 3 times something, one of these, if it's one of these, make sure you put the parentheses. It's 3 times what's inside, not 3 times a number. We did not say 3 times a number like here. It's 3 multiply something in parentheses. That thing is the difference of n, a number, and 4. So we close the parentheses, hence the comma here. Basically, that closes the parentheses. If you want to be grammatically correct about it, that closes technically these parentheses. What else?
Plus
Minus
10.
Plus 10.
Plus 10 increased by 10.
Decreases. That says decrease.
So increase is the opposite of decrease. minus, and plus. I'm avoiding the typical words added to, minus. Everybody knows those. Okay, these are the, maybe the words that are not commonly used, but that's what you need to be basically using or knowing, in addition to the typical ones like add, subtract, divide. Instead of using divide here, I used quotient. These are the unfamiliar ones. The other ones everybody knows.
Sir,
That's
I know you just said
yeah.
it, but n minus 4.
The difference.
How?
So the difference of n and the difference of a number and n. So if you look at this by itself and just ignore everything else, the difference again means minus of two things. One
so it should be
and 4.
minus n.
Nope. The difference, just like the sum. So when you say sum, it's got to be something here and something here. When you say the difference, also something here and here and so on. Okay, the difference between what? So we have a minus, but it has to have two things, one on each side. Okay, so that's the difference there, or the translation. Let me think of another one. So let's say, so it's going to be a little complex. Let's say the product of number or the product of 5 product of a number and maybe subtracted from another number and 3. Okay, there's a lot going on here, but again, the expression itself will look so small. The words, take space, but the expression itself will be pretty small, just like here, a whole sentence, small expression, a whole thing here, small expression. Okay, again, try to understand first, try to label, try to translate each keyword before you put everything together. And again, it's not always written in this order. Translation is different, so the order depending on the context of the whole sentence. So the product of 5 and a number, you may actually do it like part by part. The first clause here, the first clause. Let's translate that one by itself. The product of 5 and a number. That's simple.
5x.
5x or 5n. That's right, 5x or 5n. Whatever the number is. For example, a or x or n, whatever. So 5x, right? So 5. So 5x. Subtracted from
Minus.
Minus
3.
That's right.
minus
That's right.
from
The quotient.
Minus y.
Mhm.
The question, minus y divided by 3.
That's right. Very good. So the quotient here is a division. It's between one, it's another number, not the same one. If it says that number, then you would use the same label. Another number here, let's call it y.
Y
And
and 3.
3. Okay, so that's good. Let's put this together now in one expression. It would be
Y
wrong.
divided by 3.
It would be wrong in the beginning, but once we get at least the partial translation, then I'll show you the correct order. The first order will be wrong. So, 5x
minus, open
Okay.
parentheses,
no,
Okay,
y divided by 3.
no.
that's right. Y divided by 3. So this is almost it, but it's not. we need to flip some things here. So especially when you think about subtract from, when you say subtract from.
First,
5x
y,
subtracted from.
y
So
divided by
is it
3.
5?
Exactly. So we
5
need to reverse
after
this. So when you,
parentheses? Oh,
this is pretty good, but the order is not right. So when it says subtract from, so the from has to go first. When I say, for example, subtract 2 from 9, how would you do it? Subtract 2 from 9.
9 subtracted
9
from
minus
2.
2.
9 minus
Exactly.
2.
So we'd say, so you subtract 2 from 9, you're going to put the 9 first and then the 7. Same applies here, subtract from. So the from
Also, it's
goes
backwards.
first. That's right, it's backwards. When it says subtract from, if we didn't have this, if it says subtract, then this would be right. This would be straightforward. This would be correct. If we didn't have from, subtract, straightforward translation. But because of this, because subtract from, the from, meaning whatever comes after from, has to go first.
The
So this
5x
actually-
goes after.
That's right. So the quotient is here. And from that,
Then 5.
so from
But
the
you still
quotient,
have
you
the
subtract.
parentheses with y and 3, don't you?
You could still do it here, but it's unnecessary. In this case, unless if we had something else before it, but here, those parentheses are not necessary.
I guess just to get used to it.
All right, so yeah, parentheses are always good. They kind of define your numbers, your signs, contain everything, so you know.
Professor, it doesn't mean y and 3 together, like 5 and x, because it's a number and 3 means y and 3 together, no?
Together,
Yes,
but
the
dividing.
quotient. The quotient, yeah. So the quotient of what? So the quotient again has to be between two
Another
things. The
number is
division.
y and 3.
And the 3, yeah, y and 3. So in this order. So the
But
quotient
you're
of what?
dividing y and 3.
I have to use a quotient, so it's a division.
Yeah. So this is a division. So the quotient of a number and 3. So whenever you have any of these, again, any of these operations, so it has to go in the middle. And it's got to be at least one thing on each side, at least. So that's, these are pretty much maybe the most complex ones. Again, I didn't do the easy ones like add 5 to a number or subtract or minus 2 from a number, whatever, something like that. So these are maybe the most challenging ones. You'll find more examples of these in the book, more practice, more words, I mean the whole table and so on. So just be careful with the translation. We don't have a formula for all. When it comes to translating, it's based on your understanding. Just like when you read an essay or something and you comprehend what it's about, it's all about. Same thing here. Words can be different. I don't have a formula for all I have translations for the words, and not the formula for the translate each word. So just read it a few times and translate it to the best of your understanding.
Teacher.
Yes?
Yes, and how do I know I need to use parentheses in this case?
So when it says, we didn't use parentheses here. So usually when it says, most of the time you're gonna need parentheses when it says 5 times something, for example. Most of the time you're gonna need parentheses with times.
Okay.
5 times is not a number. 5 times not a number. It says 5 times any of these.
But when
That's
you
when
give
you
the
need-
letter X the value, then you're going to need the parentheses in that
Right,
case.
unless it says twice a number or 3 times a number. If it says this, it directly means 2n to x, whatever. If it says 5 times something, that thing has to be in parentheses. So most of the time, it's going to be one of these things. So 5 times either difference, addition, subtraction, whatever it might be. But if it says 5 times a number, that's a direct multiplication 5 times. So I believe you only need parentheses when it says something multiplies something, 5 times something or 10 multiplies something. That's the only case I believe when you need parentheses. I don't think you need it for other stuff. Even here, we didn't need it. We didn't really need it because, as you can see, it's fine. Okay, so those are the translations, or at least some of them. But again, there's many other words we can use. We can't waste all of them. So the last thing we're going to talk about here today is the equations. So the equations, we're just going to briefly introduce them. We're not going to actually solve them, but we're going to introduce the equations. And how they relate to expressions. We won't solve them, but in the future, we're going to have a whole class on just solving equations. Today, we're just going to check some solutions, that's all. So equations and expressions. So the expression, again, as we said, is a combination of numbers and letters. For example, 2x minus 4 is, for example, 8. I mean, before this. So this is an expression, okay? An expression, numbers and letters. How do we make this into an equation? What does it need?
And you have to be balanced.
Balanced. What is that symbol for balance? What do we?
Regarding English, professor, repeat the question.
How do we make this an equation? It's just an expression. What symbol makes it an equation?
The equals.
The equal
The
sign.
fact that it
That's
has
right.
a variable.
It does have a variable, but since if it's an equation, it needs an equal sign. That's why it's called equation. You gotta have an equal sign. And some.
Oh, so
some-
what we were dealing with was expressions, and you want to turn expression into an equation.
That's right. So the difference between an equation and expression is the equal sign.
The
Expression,
equality.
yeah, the expression does not have an equal sign. Equation clearly has one. So you can take an expression, add an equal sign to it, maybe some value on the other side, for example, 8, and you have an equation. So a typical question will give you expressions and equations together would say, is this an equation or an expression? Again, the difference is an equal sign. So that's an equation. This is the unknown. This is the unknown. Usually we don't know the x. We're not going to solve today to find x. Give you some possible solutions to check, not actually solve. We're going to learn the steps of solving in the future in detail. So let's try a couple of values here. Let's say, we'll see. So let's say check. We're going to say check whether x3 and x6 are solutions to the equation. Okay, we're just going to check. Again, no need to solve for it. This could be a solution. They may or may not be solutions. It doesn't matter. We just need to check them and see. So let's start with the first one. Say this one would be x3. So how do we check? How do we check this value if it's a solution for this equation?
Substituting the x
Plug it
with
in.
the number.
That's right. So just like we did here earlier. So it's all about plug in and simplify. So here it was evaluating, but now it's checking whether something is a solution. This is not an equation, just an expression we evaluated. But again, here we're going to plug x or 3 in the equation and simplify. So that's our equation. So again, just like same way we do with the expressions. So 2 times x, parentheses, whatever, x3 minus 4. So 3. That's x is 3. And when we check, we say, is it equal to? We don't know yet. So that's why we need this question mark. We need this question mark over the equal sign because we don't know yet. We don't know yet. Then you use all those operations again to simplify what we did first.
The multiplication.
That's right. That's 6.
6
equal
minus
4.
4 equal
And
8.
again, that's right. We say, is it equal to 8? Back here.
2
this is 2.
equal to 8. That's
No.
one is not an equation.
That's right.
So
So
maybe
this is So this is not right, right? This is not right. So what do you say
Maybe
about
X
three?
equals 6.
What do you say about 3?
3 is not a
What do you say?
solution for the equation.
Exactly. So 3 is not a solution. That's why we want to check whether these are solutions or not. So at least we know for a fact now that 3 is not a solution. That's all. That's the conclusion here. We're not required to find the solution. We just want to check whatever values are given. Let's try this one also. It could be a solution. It might not be. Let's find out. Only way to find out is, of course, by plugging it. X is 6. Same way, this is going to go into the equation.
2 multiplied by 6.
That's right, minus 4. And we're going to say is it equal to 8.
But it
So again, substitute.
6.
And again, follow the order of operations and see what you get.
12 minus 4.
Minus
12 take
4.
away 4. That's right. Again, is it equal to 8? Then 12 take away
8
4 is.
equal to 8.
That's right. So 8 is equal to 8. So that's good. We say that the solution checks out. Checks out, it works. So this is in fact a solution. This is not a solution, but this one is. And that's as far as we can go today. We're not going to solve again. We're just going to check. Don't worry if they don't. If both don't check out, that's not a problem. We're just checking them. We're not solving. We're going to do the solving again, like I said, in the future. A whole class on equations alone. Okay, so that's pretty much again. The whole thing today is about plugging and simplifying. Whether it's expressions or equations, plug and simplify. The rest is just following the order of operations. Any questions here, everybody, about this part of equations and solving? Everybody, any questions? Let me know. We may look at another one.
Yeah.
Okay, let's do one more. Let's say maybe 20. Minus 3, possibly x plus 1. The other side would be maybe, let's see, probably 5 and x minus 2. And maybe minus 4. This is a longer equation. It doesn't matter. It's just two expressions. So the equation is basically made of expressions. Sometimes two expressions, one on each side, or maybe just one expression here, some number on the other side. But again, don't worry about solving it. We're just going to check a couple of values here. Let me make up some values. We only need one value, by the way, here. Only you need one value. So we can. Okay, I'm gonna come up with some values here in my phone. It doesn't matter. So we're just gonna check. It doesn't have to be accurate. So I'm just gonna throw in some random values. Because again, the purpose today is not solving. We just check at least one, maybe 4. The solution here is weird. So it's a fraction. So I'm not gonna put a fraction here. It's going to be a lot confusing, but again, we're just interested in plugging and simplifying to see what we get. All right, so we're going to take the 4. We're going to plug that here. So it's going to be 20 minus 3 multiply. What's inside the parentheses?
It's going to be 4 plus
That's
1.
right.
4 plus
X
1.
plus 1, which is 4 plus 1. And here, 5.
4
Again,
minus
same
2.
4, the same value, 4 minus 2.
Throw it away.
This is not equal to, we don't know yet, so we can't assume it's equal. This is wrong so far because we don't know yet. We don't know for a fact. So we need to put this question mark. We don't know yet. Let's see if it's a solution or not. And now, as you can see, the order of operations should solve this. Let's start. We can do both at the same time, or we can
Give me a
do one at
second,
time.
please.
Okay, so where do we start from?
Your parentheses.
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 That's right.
This one is
And
5.
This is 5.
And then bring
Three.
down your 3.
20. And then start the other side at the same time.
Okay.
Also the
that's
parentheses.
5, 2.
That's right. Be 2 here. Minus 4. Back to this side. What do we do next?
17 times 12.
Multiplication.
Multiplication. So this would be 15
mm-hmm.
and 20. And here.
It's gonna be 10
10.
minus 4.
That's right. Finally.
Now it's gonna be
5.
25
Mhm.
and
Equal
6.
to 6.
6. Close enough, but no, that's not good enough. You don't.
Oh,
In math, it has to be either yes or no. So this is not it. It was maybe
it's
close
3.
enough.
Okay, so
Yeah, so it was close enough, but that's not it. So this value is not a solution. X4 is not a solution. Maybe another value. There is a solution, but again, it's a little weird. It's a decimal or a fraction, so we don't want to try that. X4 is not a solution. Okay, so whatever you do, plug and use the order of operations to simplify. That's all. It's all what we've done this class and in the previous class. It's all about the order of operations. And this is basically when you need the x's and y's. This is the infamous x, y's in math. We just use x to label. It's a name, just a name for a variable that we don't know, or that value that changes. That's all. With equations, usually we need to solve them to find the unknown. But today is not the solving. It's not about solving. It's about checking some possible solutions. And we're gonna solve equations and details in the future, like I said. Okay, everybody, any questions here about any of this? Please let me